It's imperative that we solve the challenges of reducing global warming and carbon emissions. Changing the way we use heat and power in our homes is one way of doing that. Micro-CHP, or combined heat and power, is a groundbreaking new boiler technology which has the potential to completely transform the way electricity is produced and distributed.
There are already industrial CHP applications used by large sites such as hospitals, but Micro-CHP is really the application of this technology in a domestic way. The Ecogen Micro-CHP that Baxi have developed is just like any normal wall-hung boiler. It can be hung in your kitchen, your garage, but what's special about this technology is that whilst the boiler's on and it's providing your central heating and hot water, it's also using that heat to generate a kilowatt of electricity. That electricity can be used in your home or it can be exported back to the grid.
The device producing the electricity inside the Ecogen boiler is a Stirling engine, which was invented almost 200 years ago. Unlike the internal combustion engine used in cars, it consists of a sealed chamber with two interconnected pistons that move alternately between areas of hot and cold air or gas. There are no explosions, so it's very quiet. And most importantly, it's extremely efficient.
90% of the energy going into an Ecogen comes out of it as either heat or electricity, whereas generating electricity through a power station is typically only around 30 to 40% efficient. The homeowner gets a reduction in their electricity bill, but it also offers very good carbon savings because of the greater efficiency in producing electricity on site in your home than producing it in a centralised power station.
The Ecogen boiler is already on the market, but Baxi is also working with the University of Birmingham to develop a more advanced micro-CHP system. The Innertech boiler produces 3 to 4 times more electricity than the Ecogen boiler. It runs on a hydrogen fuel cell.
Hydrogen is a fundamental material in the universe. It's in everything. It's in water, you know, it's in the polymers of my shirt, it's in my body. Hydrogen's everywhere. It's so easy to make from thousands of different methods. Now, of course, it's very clean and efficient. So that makes it the ideal vector, the most flexible fuel people have ever discovered.
10, 9...
Hydrogen, a fuel often used in space rockets, does not exist in pure form on Earth. It's found, for example, in water and fossil fuels, where it binds chemically with other elements.
We have a liftoff.
At present, the most economical way of getting pure hydrogen is by extracting it from gas. This is the process used in the Innertech boiler.
It's an interesting device because it's using the same gas right now that drives your gas boiler. The gas comes in, but in this box, you convert that to hydrogen. There's a little chemical plant in there, makes hydrogen. That hydrogen then goes into a fuel cell, which is a little stack, like a battery. That produces electricity, which you can then drive your house with. And then, of course, heat's coming out of that, because as you produce electricity, you get a bit of heat. It's a byproduct. That heat goes into a hot water tank, just like you do with your ordinary boiler. This is a fuel cell system, and it works in a very simple way, a bit like a battery. But here we have the guts of it. This is a polymer membrane. You can see a plastic membrane. That plastic film is very important because ions, hydrogen ions, can go through it. So it's an electrolyte. On one side we've got a black electrode, a black covering, and on the other side we've got a similar black coating. And these are the two electrodes. And we feed hydrogen to one side, oxygen to another. They don't mix, they react across this membrane.
As the hydrogen molecule hits the membrane, it is split into protons and electrons. The protons can pass through the polymer or electrolyte. The electrons cannot and are conducted through an external circuit, creating electricity. On the oxygen side of the membrane, the electrons recombine with the protons and oxygen to form water, which is the only waste product of this process.
Overall, this is 90% efficient, and 30% of that is electricity, which is very valuable. If we have 20 million of these units in Britain, we don't need any big power stations. We have a distributed system. Everybody's producing a little bit of electricity and much more efficient and clean than we have at present.
One of the main problems of hydrogen-based technology is that hydrogen does not exist freely and has to be extracted from other substances.
It really is quite easy to make it. Of course, you've got to provide the energy supply, and the real question is, where does that come from? Because if we get that from a coal-fired power station, that's not ideal. We're still going to be pumping some emissions up in the atmosphere. If we get the right source, like biomass, wind power, solar power, then we've really got a clean energy vehicle for the future.
In 2008, the university in Baxi installed the first hydrogen-fueled boiler in a domestic house. The house is owned and managed by the Black Country Housing Association.
Hydrogen fuel cells are a key part of our energy future. As a landlord, our interest is in renting properties to people. In 2050, we're told carbon fuels won't be available at an affordable price, so something else will be needed. And hydrogen fuel cell technology looks like it could be a very important part of that future. In most combined heat and power systems, you get much more heat. And increasingly, with better insulation in houses, we don't want as much heat as we want electricity. And the fuel cell is the most efficient system for converting fuel into electrical power. This is a beta fuel cell, and you can see the size of it. The gamma, which is the next series, is a third of the size.
This box contains a lot of things which you've got to get a lot smaller, and in fact 200 components here. We need to shrink that probably to 50 components. It takes a lot of development. We have to get the materials right, we have to get the design right, we have to get the costs right, the lifetime. All these questions come up, and it's a real engineering project in that sense. It's not just one thing you've got to solve.
The response has been incredible. I spoke to one gentleman last week. He just can't get over the fact that he's generating his own electricity, and he said he can't stop watching his meter spinning backwards.
Engineering is a solution to real problems. For example, can you solve the energy crisis? Can you solve the problem of emissions we've got on the planet? These are the things that engineers can address. They might say that's too ambitious. It's not really, because a small thing like a fuel cell could solve a lot of the planet's problems.